Okay, so today I'm going to be going over a MacBook Air motherboard that is water damaged. I'm going to show everyone how to quickly and effectively diagnose an SMC failure over other failures on the board, and basically how to test to see if the SMC is dead before you spend too much time trying to find out what it isn't, basically. So this board has been water damaged, and first thing we do, we plug it in and see what it does. So let me find my adapter, which I have no idea where it is. Here it is. Oh, it's on the DCM board. So first thing to do is plug it in and see what we get on the charger. So plug it in. We get a dim green light in the charger, which has changed from earlier. Let me see. It's not seated well. So plug it in, and we get a very dim light in the charger. That could mean the SMC is stuck in a reset state. We get no fan spin and no signs of life. CPU is cold. So let's go over how we would diagnose this and how we would find out if the SMC is the cause of this issue. So for the SMC to turn on, SMC reset L needs to be at 0 volts. So SMC reset L is going to be at 3.43, 3.44 volts until the power will stabilize, and then it will, once the power will stabilize, it's going to drop to probably it'll drop to 0 volts, not probably anything. Give me 1 second. SMC reset L will drop to 0 volts when the power will stabilize, and the SMC will turn on, and the SMC will take PP bus G3 hot and either change it in either from 12.23 volts to 12.56 volts. On a MacBook Air, it'll be 8.2, and it'll bring it to 8.6. So one second here. I'm just going to share the live stream on the MacBook support group to get some more viewers real quick. Okay, so let's put our multimeter in serial mode, and let's figure out what's going on this board. So turn it on, open the data logger, make sure you guys will be able to see it. Where is data logger? Here it is. Okay, so it's in RS-232 mode. Now we can start. So plug back in the charger and get a dim green light still. So first rail to check is PP bus G3 hot to see where the voltage is at. So if the voltage is at 8.6 volts, we know the SMC is turning on and most likely working. So usually this will show up on the backlight views and OL. So we need to change our range. I'll be using the MacBook on our second stream tonight. I'm just using this because I have the multimeter software, so we can see this is at 8.7, about 8.2 volts. So our SMC is not turning on. So what does this mean? Does this mean it's being held in reset mode and not turning on? That's a very good possibility with the green light not being on the charger, and a dim green light. So let's see where SMC on-off L is. On this board, this is a 820-00165, mid-2014, I'm going to say. Now, a couple of things are going to cause SMC reset L to be held low. Could be dead SMC, and that's probably what we're looking at here. So this is going to show up on the other side of the board near the ISL. So it's going to be, let me see. QSTEC, I could do that, but the issue with that is it's going to run on dedicated graphics. So SMC reset L is 3.3 volts, so it's being held in a reset state. Now, theoretically thinking, this could be two things. This could be a blown pull-up resistor for SMC on-off L. This could be, I'm not on-off L, SMC reset. It could be dead SMC, or it could be U51110, I believe. Not 100% sure on that. So looking at the board, let's find that chip. Looks fine in this area. SMC area looks nice. So another possibility is corrosion under the SMC. So let's look at our reset L chip. R5100, we could check that resistor just visually and see. So R5100 is going to be right there and looks fine. Could measure that in a minute, but I don't think that's causing an issue. So let's go ahead and look. This chip is on the other side of the board. We're just giving it just a visual look to see if anything looks odd on it. And what side of the board this is on? This is okay. Here our Wi-Fi chip, and this is probably going to look fine because it's the SMC. Yes, there's no sign of liquid damage on that chip. So now let's think about something. What if there's something under the SMC, or there's something under the SMC that's causing it not to turn on, like corrosion, busted solder ball, something. So let's reflow. This is one of the few things that you can reflow. That'll be a permanent solution. So we're going to surround this with Flux. So if SMC on-off L, here's another method we could use. We could take the chip off of the board and see, no, it wouldn't. It would stay at 3.42 volts. Now hang on a second. If I took that chip off, it should go down to, no, it would stay. So it would stay where it's at. Just thinking. Plug in my FUME extractor here if I could find the plug. Where I put the plug. So we're going to give the SMC a reflow. And what we want is to make sure we could see that the chip is moving around when we heat it. So I'm going to go max airflow. I'm going to go about 400. Go at 415. And when you're reflowing the SMC, Always start from far away. Never move right on it. You will burn the chip. This is a big chip and you need to preheat it. So preheat it about an inch away until you see the flux is burned away. Once I see the flux is burned away, you can move in on the chip and actually reflow it. And you're gonna wait until you can see it start to move with your air. And I see it moving, liquid, we're good. So I'm going to let this cool off. Make sure that nasty flux is sucked up by the fume extractor. And we're going to retest it once it cools off. And that's the smoke detector, of course, because my fume extractor misses a majority of the fumes. Or they have a leak somewhere, so let me fan this so it shuts off. I think what I did when I moved my fume extractor, I busted the hose somewhere at the top, so it's leaking the smoke out of the top, because it never used to do that, so I need to look into that. So it should be cooled off enough. It's still a little warm. I'll just do this. Yeah, that never used to happen until I moved it around, or it could just be because I used a lot of flux. Could always put my attachment back on. I think it will. I generally don't like this thing because it's bulky, but it seems to help. So. Yeah, that may be another solution, is to take it out of the ceiling. So I can put this fan assembly on here and should help get more of the fumes. It's just bulky, it's hard to work with. I use the light to hold it in place there, that's good. So now we're going to retest this SMC once I run this around real quick. Okay. So let's plug it in and see what we get. Same, no green light in the charger. And we get no fans done. So let's check what PP brush G3 hot is, and we always know it's going to be 8.2 volts because this SMC is dead. So when PP brush G3 hot is at 8.2 volts, it's usually always 8.5 volts. So we have PP brush G3 hot. So this may be a issue. So 8.6 volts. So the SMC is turning on now after reflow. So maybe in this case there's a messed up something or other. This has had rework before on it in this area. So maybe No, I don't really feel like doing that tonight. No, the SMC is probably dead, given the fact that that's at 8 point. So why might not we be getting fan spin? So my connector's plugged in, that's one thing. The SMC is being held in a reset state for some reason, and this is a dead SMC. That's why I titled the video like that, to show you guys what to find, what to look for in PP bus G3 hot when it's low like that, when it's 8.2 volts, and when SMC reset L is being held high. That's another key sign of a dead SMC. That's pretty much it. You know, I used the largest nozzle that comes with the Quick. It's a 8mm. So, and this has plenty of power. The small nozzle on the Quick is this size. If you could see that. So compared, it's a good size difference. A lot of times the chip will have corrosion under it. Could try and reflow it again, since we did make some progress, but it's not really going to do anything. At least I don't think it will. Could try it. Why not? Doubt that'll do much, but let's see. And there goes the smoke detector again. So my fume extractor must be leaking when I moved it. I must have busted the hose. That's my only guess on that. I think, where would I have busted the hose on this thing? Because I moved the whole setup around, so might have hard to say. So plug it in. Nope, still no fan spin. Dead SMC. The voltage, if the SMC was working correctly, it would be 8.6 volts. Oh, the fan is spinning. The fan is spinning. So hey, this was just a solder ball issue. The fan is spinning. So let's see if it boots. Didn't even catch that. I figured it was dead. This board is pretty hot. Should let it cool down. So I just freeze sprayed the area to cool it down. That's fine to do once in a while, just don't make a habit of it. So hey, this may be fixed. Let's see. Fan is spinning. So this was not a dead SMC at all. This was just needed a reflow. That's unusual. So yeah, so this is working. That's interesting. And we'll be back streaming in a little bit about Apple's thermal design, but we just wanted to make this video to explain what to look for when what to look for in SMC failures, and apparently this was not an SMC failure. This just needed a reflow. So that's one of the rare cases when I get lucky and it's just needs a reflow, which is strange. So I just plug the battery in, see if it boots up again. Yep. Okay. So this is fixed. I was not expecting that. I was expecting it to need a new SMC. That's fine. So this is going to go back in the slot, and this will not be reassembled today. This is still waiting for a couple of things. This needs a new I/O cable as well. So that's pretty much it. And this is one of the rare cases that it would work with a reflow. But just to recap, if your SMC is not turning on, PP bus read throughout will be 8.2 volts on a new MacBook Air, or 12.21 or 12.23 volts on an older one. If it is working, it'll be 12.56 or 8.6. So I'm going to switch laptops, and I'll be back to talk about Apple's thermal design here very shortly. So thank you all for watching, and have a good night.